1.3 notes that were not in the first video. This is video part 2. So today we are introducing logarithms, the definition of a logarithm. We already talked about in class that the logarithm is the inverse of an exponent. So they are the inverse of one another, just as adding and subtracting are the inverse of one another, multiplying and dividing are the inverse of one another. Logarithms help us find the power of a number when that power is not a whole number. So far you've dealt with 2 to the third, 2 to the fourth, right? And we know that 2 to the third is 8, 2 to the fourth is 16. But what if I want to know 2 to the what power equals 12? I don't know what that is. I know it's somewhere in between the third and fourth power, but I don't know exactly what. So logarithms are going to help us answer that question. So when we write logarithms in and we say, for example, 2 to some power equals 7. Okay, that means 2 to the x power equals 7. 2 to the x power. That's what we know from writing exponents out. Okay, and you will need to be able to convert between exponential and logarithmic equations with great ease. I'm going to emphasize this. This is a really important concept. You must be able to flip back and forth between exponential form and logarithmic form. So, if we're going to convert the first one, let's take 2 to the third equals 8. Okay, let's make this a little bit closer. So, the standard form for a logarithm is the log, you have the base below the line, the answer above it next to log, equals your exponent. So, exponential form is something that we're used to. That means 2 to the third power equals 8. The difference with logarithmic form, and I kind of encourage you to think of it like this, it's kind of a circular pattern. 2, the exponent is now what's isolated by itself. 2 to the third power equals 8. It's just rewriting that function. Okay? So, 5 to the negative second is 1 over 25. The way we write that as a logarithm is log 5, 1/25 equals negative 2. Again, tell yourself, 5 to the negative second equals 1 over 25. Okay? If you kind of make yourself some blanks, kind of helps to fill in. You always know this is going to be your exponent, this is going to be your answer, this is going to be your base. So if we're using 4 to the 5th equals 1024, 4 is your base, the answer is 1024, and your exponent was 5. Okay? 2 to the 5th equals x over 2. We don't even need to know what that answer is yet. It's going to be 2 to the 5th equals x over 2. Okay? So now we're going to have some practice writing in logarithmic form, and then by the same token, flipping them around to exponential form. This you have to be very, very adept at. I can't emphasize that enough. We're going to do practice in class. I'm going to quiz you on this. You must be very good at this. Okay? It's not optional. You have to be good at this. So, for example 1a, I know my base is 3. So to convert that to log form, I'm going to log 3. My exponent is going to be out here by itself, and my answer is y. Okay? I'm going to have you go ahead and do B and C on your own. I think you have enough examples to look at, and hit pause on your video, and then come back and check your answers. Okay, now that you're back, let's check to see. So we have log, our base is 3, our answer is 27, so that goes right next to our base, and our exponent is our variable, it's our unknown x. So log 3, 27 equals x. And that's how you would say that, log 3, 27. Okay? For C, our base this time was x, our answer was 32, and our exponent was 5. So some number to the 5th power equals 32. You should also be able to solve these, which you're going to do down lower in example 3. Okay, now let's convert back from logarithmic form, log form, back to exponential form. So I'll help you with A, and then you'll do B and C independently and come back and check your answers. So it's the base to the exponent gives you your answer. So in this case, it would be 3 to the 9th power equals x. Go ahead and try to rewrite B and C, and then come back and check your answers. Hit pause now, please. Okay, so now you should have written your equations in exponential form, not in logarithmic form. So this should have been 2 to the x equals 8, and C would be 5 to the 2nd power equals y. Okay? So, now that we know how to do that fairly well, now we're going to solve logarithmic equations. Sometimes it's easier to do that by rewriting it as an exponent. So now we're going to go down, and to me, it's easier to convert this into an exponential equation in order to solve that. So first of all, write that in exponential form. Give you a minute. What I come up with is 3 to the 4th equals x. 3 to the 4th power equals x. Okay? So I know that means 3 times 3 times 3 times 3 equals x, so I should get 81 equals x. For B, it's x to the 3rd power equals 1,000. Something to the 3rd power equals 1,000. The nice thing about multiples of 10 is it's simply that many zeros. So 10, one way you could solve that if you had to was take the cube root of both sides. The cube root of 1,000 is 10, so our x equals 10. I guess we should write that the same direction to be less confusing. Okay? For C, use the circular pattern again. So 2 to the 5th power equals 4x. 2 to the 5th power is 32. Dividing both sides by 4. So x equals 8. So that's the logarithm page for Module 1.3. We will be going over these in class, and you will be using logarithmic form more in 1.4 and 1.5.